Hi, good morning, Prof. So today I'm going to present on my project, individual project, and today is called Outsmarting the Way Forward. So this application is based on blockchain, and we want to actually help individuals to have a better financial transaction experience by streamlining the whole fund transfer process. So without further ado, let's jump into today's agenda. So we will first explain about situation analysis, about the current solutions that we have, and what are the drawbacks that they have, and whether we can actually solve that. Next, we will talk about the proposal, as well as the implementation, and then we will talk about the challenges that this application will face, as well as the future directions. So these are the current fund transfer technologies. We have two categories. First, the real-time bank transfer. So for real-time bank transfer, we can actually see that there's the DBS PayNow for in Singapore context. And for American base is Venmo and Zelle. So this application allows individuals to send their fund immediately without actually do any netting activities. The next category is transaction tracking, as well as lazy bank transfer, which is splitwise. This allows the individuals to track all the transactions and at the end of the day do a simple netting, and individuals can then send the bank transfer and the fund transfer at the end of the day. So what are the following drawbacks that all these applications have? So first is security. Fingerprints and passwords are vulnerable to hacking. So just recently, new findings by a group of researchers have successfully simulated a set of artificial master prints that could match the real prints more than half the times. Thus, this proved that fingerprint authentication actually can be easily be fooled. Next is convenience. To ensure better security, convenience will then have to be compromised, as users can make transactions over their iBanking account through their computer, which allow for 2FA authentication. However, if these individuals are going to do these transactions every day, then they have to do this 2FA authentication every day. And what's worse is that imagine they have to do the transactions multiple times a day. They have to do these 2FA authentications every day for many times, which is not going to be very efficient and feasible. Next is credibility. So for Splitwise, which allows users to record their transactions first, it also really enforces the transactions strongly and does not really give much assurance to the creditor. And Splitwise is thus only useful in cases where transactions are done among friends or people we have trust in. So let's talk about our proposal. So our proposal is to actually have an application which acts as a counterparty to both sides of the users. And this application will record down all the transactions in the blockchain ledger. And only at the end of the day, then all these transactions will be consolidated and checks will be done to ensure the legality of the transactions, to make sure that they are free of hacking and illegal activities. And then the bank will actually do the actual fund transfer. So the implementation wise, we have 5 features. First is creation of user accounts. Next is creation of wallets. Thirdly, creation of transactions. Fourthly, blockchain mining. And fifth, consensus of blockchain. I will talk about the implementation later and show a walkthrough of the whole demonstrations. So let's move on to the challenges. First is banking regulations. The banks have to approve this application and integrate their existing services. So we expect that the initial adoptions will not be as high as what we can actually expect. And there's inertia on the bank's part to extend their services to more platforms. And whether this is legal in today's current banking regulations still remains a question. Next is the robustness of the security analytics tool. It may not be very easy to identify a fraud, even though it can be argued that the hacking signature can be learned by the algorithms to identify these features. Hackers will also learn from this and they will innovate their hacking practices to bypass the security tool. And with the evolving security threat posed by hackers, this robustness of the security analytics tool may actually be an obstacle to us. Next is the potential loss of data from blockchain consensus. So later during the demonstrations, I will show that when there are more than one node in the network, a consensus process will be done. And in this process, the node which has a longer chain will be copied over to the other nodes. As a result, some of the records and the nodes which are being replaced may be lost. These transactions could be critical and may result in large financial losses. And next is the issue with containment level. The issue of setting a right containment level and making sure that it meets the needs of every individual is a crucial one in implementing this application. So one of the solutions can be to allow the individuals to set their own limits, just like how the current iBanking system works. So should the individual set a higher limit, he will risk making a more substantial loss in the event of hacking. And then there's the issue with irreversibility. Because with blockchain, all the transactions which are submitted will be pushed for mining. And after all the mining is done, all the transactions are finalized, and one cannot really reverse their transactions as blockchains is immutable. So in this case, the user has to call the bank personally to intervene the system and to stop the transactions from going through during the end of day processing. Now let's talk about future directions. Just now we talked about the containment issue, so now we want to simplify the containment measure. We can actually impose the limit on the transaction rather than on the wallet itself. However, imposing a limit on the wallet itself actually adds a layer of security. Hence, an additional identity check can be done to ensure that the user who creates the wallet has the authority to do so. And we also want to deal with the issue with irreversibility. So, just how we said that the blockchain as a ledger, we can't undo the transactions. However, we can actually add another functionality of undoing the transactions, which does a corresponding transaction in a reverse way. In this case, the netting will actually undo any transfer of funds. However, the drawback of this approach is that individuals can go against their financial contract, which can result in legal and ethical repercussions. Lastly, we have to deal with loss of data from consensus. We can actually implement a loss mechanism to ensure the consistency of all the blockchains. For example, for any mining of block, the miner has to get a permission from all the nodes to ensure that all the other nodes are not doing any other mining activities before starting to fetch the most updated blockchain and execute its mining. However, this may result in a reduction in mining activities and may slow down the whole process of recording the transactions in the blockchain. Now, I will show you demonstrations of the whole application. So let me quickly set up this whole process. So over here, I will actually create two peers, so two nodes in this demonstration. So first I'll run this. So let's see what we are trying to do here, right? First, over here, we are trying to create a node that is listening on port 8000. But over here, I'm going to listen, for this node, we are going to listen at port 7000. And now, when we go over here, alright, so this is the node at 8000. Over here, because the database that I'm using is Postgres, and it has actually effectively cached my session, and that's why you can actually see that I'm in my login status right now. So let me log out. Over here, I can show demonstrations of how to actually create an account. So here I can actually create like jack@gmail.com. Right, Jack. So password I'll give a simple one, 123, and I'll sign up. Right, so I'm in Jack account, and over here I can see that because of my previous database, I can see that there are wallets created by myself, Chong Yen, right? 2 accounts, 2 wallets, and 1 is by Alice. So I want to create a wallet by myself and start transacting. Alright, so here I've created a wallet myself, and I would like to actually change the wallet name. So here I'm going to identify my wallet as Jack, and this is the only wallet I have, so I rename it. Right? And over here, I'm going to start doing transaction. So currently my transactions is nothing. There's no transaction on the blockchain. Now I will initiate a transaction. So Jack, I will send to Chongyan. Alright, so the first amount that I will be sending is 10. Alright, actually make it simple a bit. 5. So I will progressively send a transaction that is 5, 10, 15. So in this case, we are able to see that later on we will see that the balance will be 20, because 5 plus 10 plus 15 is actually 30. And the wallet limit that is given to us is 50. So 50 minus 30, the remaining sum should be 20. Let's do this transaction right now. Okay. And then I'll initiate another transaction. Alright, to myself again. 10. And then I will initiate another transaction. 15. Alright, so here are the transactions that, for here the transaction on the blockchain, because I haven't really mined all these transactions, so here you can see that there's no record updated here. However, you can see that over here, the next block, all these are going to be prepared to be mined. So let us go here and say mine. And then we can see that the block is mined successfully. When you go over here, you can see that this is recorded in the blockchain. And over here, we can also see that all these transactions are being recorded in our blockchain. So 5, 10, 15. Next, we will see the wallet amount. So you can see that for Jack, I actually have created this in my ledger as well. And to see the amount, we can go to my account and click on Jack. So the balance is 20. Yes, we are right. So there's a public key as well as the private key. And this will be explained in the report about why we actually need these 2 keys. These are just essentially to create the digital signature that we need to creating the transaction. So now I will show you how to do a consensus in 2 blockchain. Alright, so previously I've created one that is listening at about 7,000, but over here is 8,000. So let's create another one. So let's just go to this 7,000. So in the real case scenario, this 7,000 will actually be another node, which is another server that is serving this process, right? So why is it taking us so long? All right, let's hold on for a while. Okay, never mind. Let's restart this whole thing. Alright, so now we are at 7,000. And over here, because of my computer cache, as well as the postgrad, they are recording my session, and that's why you can see that I'm still logging in Jack. But now if I want to change my account, right, I can actually say I want to log out, and I can log in again. So now I'll log in as Lee Chong Yen, and my password is 1234. Now log in. And currently now we can see that there's no block on the chain, and that is something that is very strange. And because previously we have actually recorded in 8000, but it's not recorded in this node. So to do that, we can actually go to nodes index. Currently we are not tracking any of the nodes. So we want to be part of the bigger network. So here we press configure. And over here, I will fetch 12708000. So the whole of this URL, I'll register it. So after I've registered, in order for me to fetch all this transaction on blockchain, I will go here and say resolve. And we can see that our chains are being replaced by this. Because previously our blockchain is empty, and now when they know that something, another blockchain that's longer than our own blockchain, they will actually do the whole consensus of blockchain and do the transfer over to replace our own blockchain. So here, after that, we can go to home, and I can see that the transaction is over here again. And when I go to next block, yep, there's nothing. When I go to index, yep, that's the previous transaction on the blockchain, right? So, yep, so that's all for my demonstrations. And over here, we can actually see that because just now I sent the amount to my wallet, over here, I can go to my account and I click on Chong Yen. I can see that there's $44. So these are the balances after everyone has transferred to me. The reason why this is not above 50 is because previously I've done a demonstration and other demonstrations that requires a transfer of funds from Chong Yen to Alice, which is another account. And that's why you can see that the amount is deeply depreciated over here. But after we have done the transfer and some top up over just now from Jack to this account, we can actually see that the balance has increased to 44. So that's all for my demonstration. Thank you, and I hope you really enjoyed the video.